Hey guys, welcome to Conversations in Ken's Café. It's a pleasure to be here. I'm your host, Ken Somerville. Today, I want to talk about the essential tips for growing resilient plants. So, all plants or all organic life forms on our planet rely on cell division to grow. So whether that's me and my heart cells, my eye cells, my skin cells, etc., or our plants, our leaves, our stalks, our roots, everything, everything that's organic out there relies on cells to divide to grow. So if you want to grow a stalk, say of a sunflower plant that's 10 feet tall, you're going to need hundreds of millions of cells inside of that stalk to have it grow to that size. So the cell division and what controls cell division is one of the most important things that you need to understand. So cell division is literally controlled by the biology that gathers the material to make the cell and create it, and the biology that builds the cell, puts all those components together. So think of it like a construction crew at a building site building a new home. They have the delivery come in with all the lumber and materials to build that. And then they have the work crew come in, take those materials, put them together and create a house. You can look at our plants and our own bodies for that matter as a house for the biology, a house for those cells, a house for that heart in my chest that has a specific job to do. Understanding that basic knowledge of cell division and that you need to create healthy cells to create a healthy, resilient plant, just like a healthy, resilient body. And we understand through all of our research and a lot of the scientists that we've had on our programs that function is controlled by the biology or the microbiology, if you want to term it that way. For personally, guys, because biology is everywhere and in everything, water, air, soil, etc., the biology I just use as a broad term, and it encompasses all of the biology that exists, in our and on our planet. So to have a resilient plant, you need resilient biology. So how do we create the resilient biology? Because that's what it really boils down to for creating a resilient plant. We need the components necessary not only for growing and creating that plant and the cells in that plant, but the biology itself. It's like if I put, a crew of 10 people out there to build a house, it's going to take them, a week, 10 days, 2 weeks, a month, however long it's going to take, depending on how good your crew is, right? But if I put 1,000 or 10,000 people out there to build that same exact house, it's going to go up in hours, a day. All of a sudden it's going to be done. All those materials are going to be used up and you're going to have this house. That's your cell. That house is your cell. And you want the best components in that house. You want, the best, of everything, the highest grade of lumber in there, the highest grade of wiring, and the highest, furnace and HVAC system. You want the best of the best. You want the best components. For our plants, those components are drawn out of our soil. What's in our soil? What's in your soil? We need sand, silt, clay, and organic material. We need it balanced. Just like we're supposed to eat a healthy, balanced diet. Well, how about our plants? Okay, you want to eat those plants, you want to consume, that lettuce or that corn. Okay, you want it healthy and vibrant, you know resilient. You don't want bugs to be coming in and consuming your crop. By combining the four base materials, the sand, silt, clay, and organic material, you're creating what you need for the biology to have homes. Okay, just like you want a home, okay, they need a home as well. Mainly that's going to be on and consuming that sand, silt, clay, and organic material. The biggest thing that you need to understand is it is always faster, more economical, okay, to have more materials available that don't have to be decomposed. Like a grain of sand would have to be mined by the biology to get the calcium, to get the selenium, to get all the different components out of that grain of sand. You need a massive amount of biology to consume that, transport it to the biology that's building the cell for your plant. If you're using organic material, such as compost, it's partially pre-digested already. That is a wonderful thing, because the smaller the components are broken down at the outset, the faster that material is used up by the biology building the cells to build your plant. The more cells can be built with the ease of having the materials there for you. The biology in our soil, in our what we want, a living soil, we want it full of biology. That's our workforce. The more we have in the soil itself, the more available materials are going to be there for your biology to build those cells and that stalk, to build that, kernel of corn that is so sweet when you eat it. Okay. You need the building blocks. Now, we talk a lot about foliar sprays to be able to give building blocks directly onto the leaf structure and stalk structure of our plant. Why do we do that? Because those materials are already at a very small size. They're a dissolved organic material, which is much easier to use. It's like, okay, I go out to the bush, I chop down a pine tree, I have to process all of that lumber, or I have to process that tree to make lumber. Where if I go and I just have it delivered and it's already cut and processed, it's a lot easier for me to use. I'm not expending the energy that is necessary to take that tree, break it all down into the lumber I'm using for my house or for myself. The more we can help Mother Nature to have these things broken down or pre-broken down, the better we're going to be. Now, guys, I haven't even opened the comment section, so I'm just going to quickly give it an open, say hi to everybody. Good morning, good afternoon, good evening, Silly Lily. Bigfoot, glad to see you're here. Does he get tired of talking? I do. That's why I always want guests on so I can talk, to somebody, guys. So Bigfoot, reach out, come on the show. Email me at it's all about the biology at gmail.com. It's always better for me not to just be a talking head sitting here, okay? And it is all about the biology, all about it. Hey, Ghetto Happy. That broad biology, yeah, the more you have, the more diverse your work crew, the better off it's going to be. Ken is doing the talking head very well. Well, thank you very much. Yeah, sand, silt, clay, organic material. You need to have those base components. Cake in the cup, good morning. I hope you guys don't mind this time slot because I'm changing Conversations in Ken's Cafe to this 5 o'clock, 5 p.m. my time, Mountain Standard. Um, just makes it a lot easier. I have a senior dog that is getting to the point where he doesn't sleep at night, which means I don't sleep at night. I get a few hours here and there. So anyway, we're going to be trying to, or we are moving all these shows to a 5 o'clock time slot, and we're going to be trying to get some more hosts on and do more stuff, not just on plants, but on the human condition, etc. You guys will have to stay tuned for that. But let's get back to growing resilient plants. So, sand, silt, clay, organic material. When you are a small gardener, it's a lot easier for you to create that environment. If you're a large farmer, then you're looking at 1,000 acres. Well, how do I put sand on 1,000 acres if I need that sand in there? Or how do I put the clay or the silt, etc.? There's all kinds of different spreaders out there where you can create this environment that's necessary for your plants to have all the base components there. Like when you do a soil test and it says, oh, you need more calcium, you need more magnesium, you need this and this. Well, you go to the co-op or the feed store or wherever you go to get those materials, and you have spreaders that spread all this material out. This is what you're going to need to do, whether it's sand, silt, clay, or that organic material. Now, guys, it's easy for the organic material. If you're a big, huge farmer, instead of chopping that straw, baling it, taking off, maybe every second year or every third year, just chop it up very fine, leave it there. That's your organic material. As long as you're not spraying the chemicals on there that are going to damage. And that's the thing with the gardeners, guys. We have to be really careful if we're buying straw to use as a cover for our soil, that we're not getting the chemicals that can be sprayed on to that, and we're not putting it on our soil. That's one of the reasons that I use wood chips, because I can get them, I can make them myself. I have, approximately 3 acres here. I have a bunch of trees, a bunch of dead trees. So I bought myself a wood chipper shredder. I do cardboard boxes. I run those through the shredder because that's carbon, and every life form needs carbon in its cell structure. Hi, Silent. Um, we have the opportunity to learn this now. 100 years ago, we didn't have this understanding. We didn't have the tools necessary to learn about this stuff. Now we have the tools to learn, and we have found out that it's all based on the cell division, and the ones that control it is the biology. So if we're growing our biology, we're growing our workforce, we're giving them the homes they need by having the different materials available for them to live on. Because face it, guys, there's some biology that like oxygen. There's some biology that don't want oxygen. And then there's biology that moves back and forth in between the oxygen loving biology and the non, and they're the transport division. They're moving materials from the area that doesn't want or need or have to have oxygen, can't live if there's too much, deeper in that soil structure, with the biology that's at the top, living in your organic material in those top layers where it's getting the oxygen. They're transporting material back and forth, and then those materials are become accessible for the biology in your plant to put the cells together. If we're breaking the mold by doing foliar sprays, by doing soil drenches, where we've broken that material down to the point where it's at molecule size instead of being, at a cell size, okay? When we break that cell down, we break the molecules out of that cell of carbon, nitrogen, phosphorus, potassium, all the different things that made up that cell. That's what our composting is doing. It's breaking those materials down out of what you have in your compost pile. That makes it so much easier for those materials that are broken down and tiny already. Because remember, we're talking microbiology. Okay, you need a microscope to see these guys. Okay, you need small pieces to go and be put into the next cell. Okay, that's where we need to focus on having the available materials and housing for the biology. It's not just them mining a piece of sand or a piece of silt or a piece of clay. It's where are they living to stay safe and create more of themselves, because all those biology, that microbiology, that protozoa that's one cell is replicating itself. The more protozoa, the more things are broken down, the more materials go into your plant, the more resilient your plant is. Okay, we need to have the materials for them to grow themselves and for them to live in. Just like us, we want a house. We want to, go out to work. We do our job. We come home. We sit in front of the TV. Etc., etc. Well, these life forms have their own cycle. They have their own workflow, but they need houses. They need protection too. That's where your organic material really comes into play for the higher life forms. Now, when we go way deep in the soil, it's mainly bacterial because they don't need the oxygen. As we move up in the different sizes of biology, and we're talking going from a single cell organism to one that's 100 cells, to one that's 1,000,000 cells, and getting up into your worms and your bugs running around the soil, and it's a collection of cells. The higher life forms do different jobs. Your worms, they're eating that bacteria, they're eating the biology, they're consuming part of it, and it's running through, they're adding their biology, it's coming out the other end in worm castings, and it's broken down. And so much easier for the biology building the cells to use, to grab onto. That's where a lot of your compost teas, your extracts, it's breaking all that material down, growing more biology, having a bloom of biology, in the compost tea, say, and you're adding that much more workforce. Now, the other key on that, and I prefer extracts myself more than compost teas, but it's making it into what's called a dissolved solid, because you're mixing with water. So it's a dissolved solid in that water column. It's at a much smaller state. It's like a fermentation, making pickles, okay, or making sauerkraut for us. Okay, it's already been broken down. It's easier for our biology and our guts to break that down, use it in for new cells in our body, for using it to make new biology in our body to make those new cells. Okay, it all works together. And that is the beauty of everything that Mother Nature has set up, is it works together. The one can't exist without the other. That's why I talk a lot about the predator prey. You have to have the food source for the biology to eat, or else it's not going to exist there. That's where you want resilient plants. You have to have enough cells in your plant for it to be healthy. You look at an aphid, okay? An aphid bites into your plant, sucks out the chlorophyll. But if there's enough cells on that plant that it's so thick that the aphid can't bite through to get to the chlorophyll, guess what? The aphid's out of there, baby. Okay, it's going, hey man, there's no cake, there's no ice cream, and there's no dessert here. I'm moving to the next plant because your neighbor's plants aren't that healthy. They never found out that they needed to do this. And all of a sudden you have a resilient plant because the plant is so healthy that the bugs don't want it. They can't feed off of it. That comes from having sand, silt, clay, organic material, having the components necessary to build more and more and more biology, which is going to build more and more and more cells. The more cells, the thicker the leaf, the more the bugs can't devour those leaves, at least the smaller bugs. Okay, caterpillar, well, a caterpillar's going to eat a leaf. Okay, sorry, it's just going to happen. You can't have strong enough deterrents in your system that you have the complete cycle of life, or the soil food web, as it's called, having the different life forms that are consuming the caterpillar before it ever comes out. You have the birds coming in going, oh, hey, a caterpillar. I think I'm going to eat this one. Okay. It's a matter of creating that life in your garden, in your field, on your farm, in your environment, whether you're in the city and you're just growing some herbs on your balcony. The more life you have, the healthier and more vibrant, more resilient your plants are going to be. Now, organic material. Let's look at different ways that you can add organic material. Hey, Broken Scepter. Mulch. One of the big ones. Okay, now I've mentioned straw. I've mentioned wood chips. You can use almost any broken down organic material as a mulch. Okay, I mentioned the cardboard boxes. Okay, I'm shredding them. You can shred paper. That's a carbon source. These are things you can use for mulch. You do not want to have bare soil. Bare soil, bad. Really, really bad. Okay, you want to have that soil covered so that not only can it retain the moisture, but if you're using a mulch, there's organic material for the biology to break down, to live in, to have their homes. Okay, they break that material down, they feed it into the biology that's in your plant, growing those cells, and resilient plant, because it's got the necessary materials. It's easier to feed plants to plants than it is to feed sand to the plant. Okay, the sand, silt, clay, those are your long-term life in your soil, vibrancy in your soil. They're the base material for everything to be able to come together to grow and have the healthy plant, because you're giving a broad range of available substances in the sand, silt, clay, and organic material that may not be there. You may need one molecule, okay, of, let's say, selenium to make one particular cell healthy, to make it to reach its genetic potential. Your plants want to have healthy cells. They want to reach their full genetic potential. Yet we have this tendency to overlook the multitude of different materials that these plants need and the biology need. That one cell of selenium might be needed to create one type of biology, and that's the biology that mine say boron, which tomato plants, by the way, really need boron. Okay, but if we don't have that sand in there where it can go mine that boron out of that sand, it doesn't matter if you have the biology. It doesn't actually matter because there's no place for it to go and mine to do its job. That's why having the whole basket of available, minerals, the available substances for the biology to use, to mine, to consume. Without that, what are you doing? You're not doing a service for your plants. You're doing a disservice for your plants. The more that we have everything available, the better off we're going to be. And that's in our bodies too. That's why eating a larger spectrum is going to give you more available materials for your body to be able to use. Just like, we know that if you eat carrots, you get beta carotene out of the carrots, and it's good for your eyes. There's all these different components that we now understand more and more are necessary for helping us build healthy cells in the human body. But then, is it in your carrot? When you eat that carrot, like back in the 1800s, that carrot was full of nutrition. Now, if you look at the amount that's in there now, oh my gosh, guys, you would just shake your head and go, how did this happen? And it happened because we killed the biology in the soil. Now, I'm not against conventional farming per se. What I would say to any conventional farmer out there, if you're spraying herbicides and you're spraying pesticides, you're spraying these fertilizers, what you need to do after you've done that, after you've used that pesticide to get rid of fungus gnats or whatever you're dealing with in your crop, go back over it with biology, because you have killed a massive amount of biology by using that spray. And you now need to go back into that field and add that biology, add that workforce back in, so that it can break down the material that's there to build more cells and healthier cells. You're going to get a much more vibrant, healthy crop, and more of a crop than you would if you just sprayed the chemicals, killed the biology, and it's got to restart. Because that's what's happening when we're spraying these materials. Hey, Shawnee, when we spray that and we kill all that biology, we knock it back to prehistoric times, it's going to come back. Yeah, sure, it is. It will grow your plant. It's not going to be enough there to grow a really healthy, vibrant plant, not a resilient plant, but it's going to grow a plant that's going to survive, or should survive, to get the crop off. But it's not going to have the resilience. It's not going to have the health, the nutrition. It's not going to have all the necessary substances in there that it should have or could have. So if you're conventional, you're using these things, Go back in after and spray the biology back on. Get the biology fired back up. That's your work crew. Okay. So you want to send in the Marines, the Navy, the Air Force. You want to send everybody back in because you've just put a nuclear bomb on your soil, on your crop, that's wiped out 99% of your biology, because that's what these things are designed to do. You want to add that back as quickly as you can. That's where it's so important to understand that we don't grow plants, we grow biology. No matter what you're doing, what methodology you're following, everything boils down to that biology that makes the cell, which is your plant. Okay? We have to really change our mindset to what we're truly growing, what we're creating. We're creating an environment where the biology can do their job. Mother Nature has set this all up for the biology to do its job, to use the materials available to it to make healthy cells. If we can't make a healthy cell, we cannot have a resilient plant. We can't have a resilient human being either. If we're consuming that, but we're growing, so let's say we're a gardener, we're growing, carrots and lettuce and cabbage and broccoli and all the normal things that we grow and eat. If we're not growing those resilient plants, if we're not growing, with the understanding of growing the biology that's growing the plant and supplying all the different components to that biology, we are not having healthy plants. We're not having resilient plants. When we consume that, we don't have the nutrition in that plant that our body has to have for us to create healthy cells and be healthy. That's why you hear story after story after story of somebody that's sick, on their way to death's door, and they change their diet, and all of a sudden they start to get healthy again. They're not sick anymore because they're supplying the right material for their biology that exists in our body to build healthy cells. And a healthy cell isn't sick. You get rid of all the sick cells, you have them consumed by your T cells, your killer cells that are running through our bodies, and all of a sudden it's replaced by healthy cells. And hey man, I don't, I'm not a diabetic anymore, or whatever ails you. Okay, all of a sudden you've created this environment inside your body by changing what you're eating, or even how you're eating it, into what your body needs for the material for your biology inside your body to make healthy cells. Now, I myself am keto carnivore. I don't eat a lot of greens. I want to feed my animal those greens because they're designed to break it down. I don't have four stomachs. Okay, I am not a cow. I'm not a rumanoid. Okay, I only have the one stomach, and it's designed to eat specific things. Now, I'm in northern Canada. If you're in Hawaii, you have access to fruits and vegetables year round. You actually have different biology in your gut to break that down more and more and more. You're having more fish in your diet than red meat. Your biology is more suited to that in your stomach. That's where, okay, I'm live in Canada, I go to Mexico, don't drink the water, because it's a different biology. There's different bacteria, there's different fungi, there's differences. And if you're living in an area where you have access to these different varieties year round, then that's what your body is going to be wanting to have. But if you're in, say, Canada, where I am, and we don't have access to fruits and berries year round, if we're not canning them, storing them so that we can eat a certain amount during the winter, our bodies aren't designed to have the same materials. That's where you eat generally what's available in your local area at the different times of year. Okay? We wouldn't be eating a fresh tomato in December or January in Canada. Well, at least on northern Canada, okay? But we'd be able to go out and hunt a deer or a moose or an elk, okay? It's the local. Okay, eat local within 100 kilometers / miles. Yeah, Lily, and that's supporting your local farmers, your local community. That farmer goes out and he buys stuff at the store and supports the local stores. Everything is really become global, where we're bringing food in from different parts of the world. And I know I mentioned this with Andy on Wednesday, the different chemicals that get sprayed into a transport truck to take that green banana to yellow as it's getting to the store. You have to understand those chemicals are not what you want to be consuming. And if you're thinking it's just on the outside, I'll wash it off the outside. Guys, come on. Really think about that. The material goes through the cell structure, has to go into that material, say that banana, to make it mature. It's going through the cells. You're consuming that. You may not think you are, but you are. Hey, Doc, there's so much that you can do to grow resilient plants. If you want to eat those plants in the winter, learn how to can. Learn how to take those tomatoes and can them. Take that cabbage and make sauerkraut. Make pickles, make this and that. There's all kinds of ways to preserve that food. That's where our natives had it right, where they were taking the materials, the nuts, the berries, etc. They were drying them out. They were making things like pemmican, basically travel bars, okay, where they could have a small amount, have all of this material there stored up for the winter, and they would slowly use that up over the winter to get them through to when they could start harvesting material again as a life came back into our plants. Our winter left and those plants were reproducing again. Resilient plants are what we're after, because whether we're eating them, the animals that we're eating are eating them and getting the building blocks. It all comes down to having the building blocks available, whether it's in our bodies or whether it's in the soil for the plants. And that all comes down to sand, silt, clay, and organic material. I keep repeating it. I know I am, guys. But when you look at life through the eyes of biology, building all the organic life forms, biology built me, okay, because it's built cell by cell by cell. It's the same thing. Focus on feeding the biology, whether it's in your body, whether it's in the soil, whether it's in the plant. Focus on giving the biology what they need. And all of a sudden you have resilient plants. You have healthy, vibrant plants that have the nutrition in them to give you healthy cattle, healthy sheep, healthy goats. healthy birds, chickens, etc., healthy fish, healthy body human when I'm consuming that, because the building blocks are there for me and my biology to use. And that's the ultimate goal. It's not just about stuffing your gut so you're full. It's about the health of the food you're consuming to make you healthy. It doesn't matter if you're a multi-trillionaire. If you don't have health, your wealth means nothing. You'll give every bit of your wealth away to heal yourself to be healthy, because other than that, you're dead and that wealth doesn't matter. Nope. Kids are going to get it. Grandkids are going to get it. They're just going to blow it. Sorry. Anyway, your health is your wealth. Focus on the health of the plants, the health of the soil. That's the base. That's the true key to life. The true key to health is your soil and your soil biology. And hold on, guys. Silly Lily's here. Yes. Oh, I haven't even been watching for Lily's saying to do a Q&A, but hey, Rory, I haven't actually been looking. She says there's a couple of questions. Let me just scroll back here. Are you guys actually putting question marks so it's easier for me to see? Okay, we're back into talking heads again. Homes of the biological homies. Yes, homes for biological homies. Okay. Let's see. What's this? Coverage of floods. Okay, talking about Australia and the floods. And guys, if you're in Australia, my heart goes out to you guys. You guys have been suffering bad floods down there. I hope everybody is safe and sound. It's not, easy to have those kind of things come through. It's, tornadoes, typhoons. It's all the same. It really interrupts. I sleep through. Oh, Ken's a light sleeper. Yeah. Okay. Okay. How about just growing in sand like Afghanistan? Sand, and let me just grab that because I have it here. Just got to grab the right one. No, that's not the right file. Just wanted to bring up, I know I've shown it on a few different shows. There it is, base presentation. Minerals. Let me just present this, guys. This is your sand. Okay. Share screen. Let's get this big size here. Okay, this is minerals in soil, and this is a global survey of sand. Okay. Look at, selenium, calcium. Look at the numbers. Okay. In the Earth's crust, in the sediment. These are all materials your plant needs, your body needs. Okay? Molybdenum, calcium, carbon, nitrogen, potassium. This is all in your sand. So if this is a basically almost complete list, then growing in Afghanistan in that sand, as long as it's not play sand, okay, it's a good quality sand, you're going to have access to all these materials if you have the biology. And that leads it back to the key is having the biology to use that. Now, can you make that sand better? Yeah, you can find some silt, broken down organic material, and it's further broken down. You're not just mining the sand crystals, you're mining the silt. And if you can find some local clay, then you can add some clay, and it's just that much better. It's like, okay, do I want a Studebaker, or do I want a Lamborghini? Okay, the Studebaker is going to get you around at 10, 20 miles, 15 miles an hour. But the Lamborghini is going to get you there a lot faster. Okay, and well, I don't know if it's any more comfortable than the Studebaker, because some of these sports cars aren't very comfortable. But just to give you an idea that yes, you can grow in sand, you can grow in straight clay, you can grow in these environments. It's better to have more available. It's like only using pine lumber when there's spruce and there's hickory and there's maple and all the different types, but only using pine because that's what I have, and I don't want to go and spend the extra money on the other stuff. Okay. How much? Still looking for some questions, guys. So I haven't been following along too much on the question side of things. And Lily, if you had a question, I'm not even looking at your stuff because you answer all you got as many answers as I got. You've been listening to me too long. Oh, yeah, and like Lily says here, you need the biology to mine the sand. So I only found the one real question there, guys. So I'm sorry if I missed your question. We'll have to do some Q&As here in the future when we get more people, asking questions. It is your knowledge that we need to increase. Mine, I've took it down to quantum biology. It's like I know I use just the term biology, and that's for everything. That's for everything that's in our air, our seas, our on land, in our bodies, in our plants. Microbiology, quantum biology, you're just getting down in sizes. Okay, it's like going from me to my size to a child, to down and down and down, but it's all the same basic thing. It's all the same basic function, and it's the same basic biology doing a lot of different jobs. Like Dr. James White, who's one of the leading researchers on biology globally. Okay, and if he doesn't get a Pulitzer sometime, I don't, or a Nobel, you know, it's things aren't right. Let's just say it that way, because he's found that the horizontal gene transfer, the biology changes its genes at an astonishing rate. When we look deep enough, we can see these things. He's literally had to go, okay, I can't track this. It's happening too fast. It's the same biology changing all the time. He's had to back out and look at groups of biology. And it's amazing to me just how fast things can change biologically, from being the plumber to being the electrician to being the HVAC guy to being the laborer. It really is an amazing thing how fast biology can flip the switch and go from a builder to a decomposer. When that leaf was growing on the tree, the biology that existed in all those cells, they were doing their jobs, they were building more, etc. When it falls off, hits the ground, all of a sudden that biology flips, starts becoming a decomposer, breaking those cells down again into its component parts for the biology that's going to be in the soil living there, and for the next year's plant that's going to be created by that same biology. That next year's leaf on that tree, okay, needs exactly the materials that was in that leaf from the first year that's landed on the ground, that's being broke down. Now it doesn't have to mine it out of sand, silt, clay, and organic material. Hey, Farmer Cheryl, it's already there. It's so much faster for the biology to break that leaf down than it is to mine all those components out of that sand, silt, clay, and organic material. That's why we do a lot of foliar spraying, okay? Because it's been broken down, it's been micronized, it's in the smallest form, and the biology doesn't have to break it out of sand, silt, and clay. It's there, it's usable, it goes right through the cell walls into the cells and can be used, can be grabbed and rebuilt. Um, should we own a microscope since we can't see with our own eyes? Which microscope and how much should it cost? Uh, Cheryl, it really depends on how deep you want to go. We've actually, on this coming Monday, we have Matt from Shooting the Soil bringing his new microscope on to help. Now, I know Leighton Morrison, he recommends the Swift, SWIFT microscopes. If you want to learn microscopy, there's different courses. I would suggest Matt Powers. This is a gentleman that's gone way deep on microscopes, in teaching, etc. You can get different microscopes to do different jobs. There's different optics, there's different lighting. You can go really extreme. I would suggest, $2, $3, $4, maybe $500 microscope. Go as cheap as you can, for your first one. Learn, see if it's something you even like. You might go, oh my God, this is way out of my league, I don't want to do this. But the only way to know you have good compost, living compost, is put it on a slide, put it under the microscope. And you can, Cheryl, check out Monday showing Matt's Shooting the Soil. You can go back on the channel. You can check out some of his other shows. I think he's been on twice before with his older microscope. And check out from that to what's going to happen this Monday with his new microscope. I think you're going to be quite surprised being able to see what's actually going on in your soil or in your compost, etc. And that, guys, that's the only true way to know if you're making a quality compost is when it's finished, or you think it's finished. Take a little bit, put it under the slide. If there's no life in there, guess what? You don't have a good compost. You got a dead compost. And you can basically start all over, or you can start adding biology, taking things that you're getting biology from and adding it into your compost pile. And these are things, and you guys in the States are fortunate. You can reach out to Ensign Algae, start with that. You can reach out to places like Fish Brew. Those earlier biologics, your algae is one of the earliest, your fish is some of the earliest biology. You throw that in your compost pile, and all of a sudden it's going to have life in it. Okay, that's one of the reasons you need to keep the compost pile moist. You need to keep it turning. It's in doing that you're proliferating the life in there, and it's not burning the life out of it. If you're using a thermophilic compost, you're bringing it up to that 150, you're literally cooking off a lot of the higher levels of biology. you need to allow that to come back down in temperature. Hey Marshall, hi Penny. You need to bring that down to temperature where the higher life forms can survive. Okay, so that's where I like the Johnson Sioux um, bioreactor for doing compost. It's a set it, forget it. You just keep it moist, don't let it freeze. When the temperature comes down, you just add composting worms, and then the worms finish breaking that down, that material, and all of a sudden, what you're left with is amazing, amazing stuff that you can take a small amount, and it looks like almost like potter's clay when it's done properly. And you can put that through a wash, just like washing worm castings, break it up. It's just packed with biology, and you can literally spray that onto a farmer's field and see amazing results. And that's what it's about. It's about the results. If you want resilient plants, you need to put in the foundation for the resilient plants. You need that sand, silt, clay, and organic material. And you need to make sure that you're adding more. Sorry. You need to make sure you're adding more and more organic material constantly. That's where cover crops, chop and drop, these different methodologies to keep life in your soil, to keep roots in your soil, to keep giving back into your soil the components that are needed. And it's easier, like I said, for it to come back out of the plant that has already been growing. So, say you got corn, take your ears of corn off, leave everything else there. Leave it over winter or put it in your compost, add it back in. But if you don't have a mulch layer, get it. Okay? Straight, flat out, make sure you have no bare soil. More roots in the soil, the more energy goes into your soil, the more energy goes into your biology, the more biology you're going to have. If you have 1,000 people inhabiting a city that needs 1,000,000 people to run, your city's not going to run very well. But if you give that 1,000 people enough time to repopulate, all of a sudden you've got the 1,000,000 people. The biology is repopulating all the time, but only if they have the building blocks to build more biology. Okay? Your 1,000 people in that city, if they don't have enough food to eat, to survive, to grow and make children and grow those children, feed those children, it's not going to be an operational city. Your biology is the same way. So we're at 58 minutes. We've got some amazing guests coming up, especially next week. We're doing another Conversations in Ken's Cafe tomorrow. I'll let you know what the topic is later, but it's going to be more about, creating healthy, vibrant plants or resilient plants or resilient us, or I don't know, who knows, maybe I'll go off on energy, frequency, vibration, or, one of the other pieces to the puzzle that brings this all together to create that healthy and vibrant plant. It is so great to have you guys come here and be with me. The people in chat, you guys are all amazing. It's just an amazing Saturday afternoon here in Canada. It's a little cloudy, but it's still above freezing, and the snow is almost all gone. I'll be able to get out and start doing things again on the property, other than just looking at the snow going, okay, now what am I going to do? I got to wait and wait. Guys, thank you so much. We'll see you guys tomorrow. Remember, Matt from Shitting the Soil is coming on Monday with Leighton Morrison. and you're going to be able to see what he sees through his microscope. So if you guys have never seen the life, oh my goodness, it's going to blow you away. Anyway, guys, thank you very much. I love you all, and we hope to see you all tomorrow.